Hello everyone. Welcome to Linear Equations in Two Variables Part 2. In this session, we will learn about graphical representation of linear equation in one variable and two variables, equation of lines parallel to x-axis and y-axis, equation y equals to mx and nature of the graph. So let's start with linear equation in one variable. For example, if we take x equals to 3. So how do we represent graphically? That is, we need a number line. Draw a number line and plot the numbers. Negative scale for the numbers. Right, now x equals to 3. So this is when x equals to 3 is represented graphically on the number line. Now if we want to take linear equation in two variables and represent it on the number line, is it possible? No. So we need a Cartesian plane. If it is a linear equation in one variable, we can represent it on the number line. But if it is a linear equation in two variables, then we need a Cartesian plane. So this is what the equation I have taken. So let us know what are the x values, that is the ordered pairs. As we have discussed in the previous session, this equation will have infinite solutions. 0, 3, 3, 0. So I'll take 4 points and present it in the Cartesian plane. So for that, let me draw the x-axis. First, this is our x-axis and y-axis. Yeah, this is our y-axis. And let us plot the scale on the plane. So this is 0, 1, 2, 3, 5, 6, 7, minus 1, minus 2, minus 3, minus 4, minus 5. We know that this is the positive x-axis, this is the negative x-axis. And here we have positive y-axis and here is the negative y-axis. Here 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Now this is our Cartesian plane. Now first point, where does this point represent? X equals to 1, y equals to 2. So this is the point where we can represent the ordered pair 1, 2. And next to 2, 1, it goes here. And next x is 0 and y is 3. X is 3 and y is 0. X is 0 and y is 3. So x is 0, y is 3. So this is how we represent. Now, when I join these points, we get a line, a straight line in this manner, joining all the points. And I write the equation as x plus y equals to 3. So this is how we represent the linear equation in two variables in the Cartesian plane. And we say that it is a straight line. And if let us take this point. So what is this point? X is 6 and y is minus 3. That means the another solution of the equation is 6 and minus 3. So 6 minus 3 is 3. So this way we can find other solutions too with the help of the graph. So every point on this number line, any point we take, that forms the solutions for the given line. As we know that it has infinite solutions. Now let us take another example and find out the solution or how the line goes. Yeah, and let me erase this and take another example. I'll take the previous example, that is x equals to 3 we have done on a number line. But if the same should be represented in the Cartesian plane, can we do it? Yes. How it is? So first I have to convert this into the general form, that is ax plus by plus c equals to 0. So x plus, since I don't have y term, I'll take it as 0y, and c is also not there, is equal to 0. So this is the equation representing in two variables. So I'll find out the ordered pairs. I know that x is always 3. Since here we can't take it as 0 because according to the equation we have the value as x is equal to 3. So this is our 3. Now let us represent x is 3, y should be 0, x is 3, y can be 1, x is 3, y can be 2, x is 3, y can be 3, and so on. So in this way we'll get infinite solutions. Now how to represent it? We'll see, and what kind of line do we get? So when x is 3, y is 0. When x is 3, y is 1. Here, when x is 3, y is 2. When x is 3, y is 3. When x is 3, y is minus 1. In this way, we can assign any values to the y. Since 0 into y will get the same. And when I join these points, I'll get a straight line which goes parallel to the y-axis. This line represents that the distance between the y-axis and the line is always 3 units. So what is a general equation in such case? That is, what is a general equation for a line parallel to y-axis, which will be x equals to a. A can be any value. Here we have 3. So in this manner, if we take, what will be the equation for a line parallel to x-axis? Generally, it will be y equals to a. Let us take any value. Let us take 3 in the same case, y equals to 3. So where we will get? We will get a line which is parallel to x-axis and which is 3 units away from the x-axis. So this is how we get the equation for a line which is parallel to x-axis. Now let us see what is y equals to MA and what kind of graph we will get for that. So I'll take one example for the same. Y equals to mx. So let me take y equals to, m is any constant, we will take it as 2x, right? So if I want to represent it graphically, I need to first get some ordered pairs for the representation. So x equals to, if x equals to 1, y will be equal to 2. When x equals to 2, y is 4. When x equals to 3, y is 6. When x equals to 0, y is also 0. When x equals to 4, y is 8. In this way, we'll get infinite number of solutions. Now, if I want to represent it graphically, let us see how it will be. Right, I'll take the axis again, x-axis and y-axis, and represent the points on it. negative scale. Since I don't need a negative scale much, I'm not extending it. Right, now let us represent 1, 2. Where is this point located? Can be located on the number line. So x is 1, y is 2. Here it is. When x is 2, y is 4. So here it goes. When x is 3, y is 6. So here it goes. And next point is both are 0. That is at the origin. And when x is 4, y is 8. So it goes somewhere here. Right. Now when I extend it, when I join these points, I will get a straight line, and we see that it passes through the origin. So what is the nature of this line y equals to 2x? It will always pass through the origin. It can be any value. That is, m can be any constant. Here we have y equals to 5x or y equals to 10x. Anything it can be. Always that passes through the origin. So without plotting also, by seeing the form of the equation, we can make out whether it is a parallel line or whether it passes through the origin, or it is a line which passes through x-axis and y-axis, or it is a line passing through the negative x-axis and positive y-axis. In this way, the nature of the equations helps us to identify where the line actually exists on the Cartesian plane. I hope you have understood the graphical representation of linear equation in two variables. Thank you.